Well, check it out. We've got an answer from a Japanese station, and also we've got a QSO with Whiskey 7 Zulu Romeo in the States. It's about 45 watts, close to 50 watts on peak. Hi folks, welcome to another episode of The Art of Engineering. In this episode, we're going to revisit the cheap Chinese linear amplifier we got off AliExpress. Now, in the last video we did on this, we managed to get it up to about 20 watts. It arrived with an LD MOS, I think it's a VHF LD MOS, and I think they're taken out of old equipment, second-hand parts, and mine was dead on arrival, so it was promising 100 watts. We all pretty much knew that wasn't going to happen. After a lot of frigging around, we managed to get about 20 watts out using two IRF 510s. What I have now done is I've gone and got myself a couple of different FETs. I got those off mini kits in South Australia. They are, I'll put the type number here because off the top of my head I can't remember it. But we're going to pop those two in and see if it makes any difference whatsoever. Let's go. So these are the FETs. There are 13N10 FETs, and they're like a high power switching FET. So we're going to take the IRF 510s out of this, pop these ones in, and see if we get any difference in the power out from this amplifier on the 7 meg band, which is the band we're testing. But then we might plug in a multi-band rig and see whether different frequencies affects the output. I'm assuming as we go up in frequency, the output's going to go down. And the idea is if we can get this up to a reasonable output that's in excess of the 5 watts I'm getting out of the Hermes, make some low-pass filters for this, build myself a little amplifier for the Hermes Lite to get myself into the, I'm hoping 40 watt range. One down, one to go. Two transistors in. We've already managed to rip a pad off, so we've already got to do a little bit of a link there with a piece of hookup wire. You know, it's going to get dodgier than this, no doubt. I just like to fiddle around, as you've probably well realized after watching a few of these videos. Well, we just got hit in the face by a piece of FET. It was probably over current on the 19 volt supply, and the 19 volt supply was smart enough to know that it needed to fold things back. I put it on 12 volts, but I forgot to wind the bias back, and this FET went off. I'm probably just going to change both of them out now and have another crack. This might be my last attempt. I'm thinking if I can't get this thing to transmit with these new FETs, I'm probably going to stick it in the junk pile. That is what a totally cooked FET looks like. There's the other part. Yeah, it went off like a gun and scared the hell out of me. Anyway, we shall continue on and see if we can do it again. This time I'll film. Okay, we have our FETs back in again. We're going to run it off the 12 volt supply. Fingers crossed we don't have another explosion. Can I have a clear prop? Well, we've got it going. That is on the 200 watt scale, giving me 40 watts on the 7 meg band. Into a dummy load, obviously. We're listening on the Hermes Lite.
This is Victor Kilo 2 Alpha Oscar Echo testing 1, 2, 3.
About 45 watts on 160 meters, 80 meters, same, about 45 watts, 40 meter band, 45 watts, 30 meter band. That's giving me about just under 40 watts. The 20 meter band, bang on 50 watts. It really likes that frequency, which is, I think, a good thing. 18 megs, that's about 30 watts. As we go up in frequency, the capacitance on the gates and these FETs is going to be a contributing factor to lessening amounts of power. But on 21 megs, we're getting about, it's still about 40 watts. 12 meter band, 24 megs, 35. And the 10 meter band. And no, Chris, I'm not going to try 50 megs. Oh, I might. Don't even know if it transmits. Anyway, let's try. You're going to make me make smoke. I know it. Let's hit transmit. Yep, that's about 45. So it does pretty well on 10 meters, and it's still below 2 SWR coming into the amp. And finally, does it transmit on 6? 50 megs. Not sure. 50 megs. Should I key down? It doesn't have filters for this band, so this isn't to a dummy load, people. It's still 45 watts. So it will transmit on that frequency. Interesting.
It's a school night. We've started winding toroids for our first filter. This is Drew Diamond's Projects for the Radio Amateur Volume 2. I've waxed lyrical about these books, and my whole station is actually powered from the first design in this book, which is the Miser's 13.8 volt power supply. It's been a godsend, linear supply, old school. I know the transformers are hard to find, but I've rewound 2 microwave transformers because I am completely crazy. We have our LC meter here, which I've zeroed to find out what the leads are going to give me as inductance. It's at 2.1, and Drew has said that 14 turns on this should give me a value of 1.3. So at 2.1, if we are, and I've obviously taken the enamel off these wires with a bit of sandpaper, 3.4 minus 2.1, can't do the maths because I am maths challenged. 4 minus 1 is 3, 3 minus 2 is 1.3, bang on 1.3 microhenries. Thank you, Drew Diamond. I can trust you, I know, but obviously cores can sometimes do funny things and not be made very well. But these cores are obviously very precise, and I'm getting the value that I was expected, covering 2/3 of the core, just like Drew told me. And am I surprised by that? No, I am not. So what we're going to do is we're going to get the other 2 wound, and we are going to make up this filter, ugly style, on a piece of single-sided circuit board. And once this is all done, I shall come back and I shall show you values in this table is what I'm using. I'm going to make just 1 filter on this board, but eventually populate this board with all the filters I need. Should my cheap Chinese amp blow up again, I will probably either scrap it, take the heatsink, use that, and maybe recreate Drew Diamond's actual design as it was intended, but with the beefier FETs that I've now got that seem to work really well with a 12 volt supply. Enough of me babbling on, because the more I babble, the lower the views go, but that's okay because I like to babble. I'll come back, I'll show you that finished filter, and then we shall pop it on the amplifier and maybe do some FT8, see if the thing actually works, and if we can run it on FT8. If it runs on FT8 without blowing up, things are looking good.
Just giving this single-sided PCB material, printed circuit board, clad with copper on one side, a rough up with some fine sandpaper, hit it with a bit of isopropyl alcohol. This is something that I don't often do, and I think it's to my detriment that I don't do it, because it makes the soldering that much harder if I don't do it. I've seen it recommended, and it literally only takes like 5 seconds to do. So okay, we're going to divide this up into 10 sections because the plan is to make this a filter board for all 10 HF bands. And I will put the 7 megahertz. I'll probably start 160, go from left to right from the lowest frequency at 1.8 megs through to the 10 meter band up here. So 7 will be somewhere in here, and we'll get that all set up. And hopefully then when it's time, even if the cheap Chinese amplifier decides to kill itself, I will have a filter board that I can use in another amplifier. So let's get our first filter done. We have our filter on the go. We haven't got the capacitors in, and we're putting in the last toroid. And I'm using this handy pair of hands here. I've used a bit of sandpaper to get most of the enamel off, but you will find that with these wires, that especially the thinner ones, thicker ones, you'll probably really need to give them a scratch. But usually 10 or 12 seconds of heat on this will melt the enamel off the wire. And you know, with some of those QRP Labs kits, you're actually put in a position where that's the only way you can get the enamel to disappear. Because if you try tinning the wires before you put them in the board, quite often, because you've twisted wires together, they won't fit through the actual board. So Hans actually says get them through first and then zap them, except for the thicker wire. But read the instructions. If you read the instructions, you will not have any problems. You need to make sure that you remove the enamel, or you don't actually have a circuit as such. So I will get all of these in, and then I will continuity test across the gap. If I get continuity from one end to the other, we know we're good to go. And there we go. So we're good to go. Let's get the capacitors in this circuit. Some coax either end. And then we can wire it to our amp. I may actually try and put some end connectors onto the actual amp so that we're not soldering and desoldering off that thing when we're mucking around. We don't want to wreck that circuit board. It's already had enough abuse. And this is where our low pass filter is installed. There's a link on the amplifier that needs to be removed. So we will remove that link and install these end connectors onto the actual amplifier. It is getting on to about 9:30, but that is the finished filter. And I had quite a few of these leads for testing and whatnot. So it says LMR 200 on it. So we are going to terminate either end of this filter so we can not only run it through the Nano VNA, test its where it's rolling off, and to make sure that it's working as a low pass filter, but I've also put some connectors onto the amplifier so that we can hook up our filter to that amplifier, and then we can perhaps get it on the air and see whether we can nab some FT8. Now, I'm hoping that once the filter's installed that we don't lose a lot of power, but in the past I have noted that quite a bit of power disappears once you start filtering, because you're probably filtering out things that shouldn't be getting through to the power meter. So we shall see. It's looking promising, we hope. And this is our Nano VNA going from 1 to 15 megs. And we can see here that's at 10 megs, it's down 19 dB already. When we get up to around 7, that's 7.7, let's go to 7.3-ish. That's about 7.3 minus 1.61 dB. That's the bottom of the band there. We're looking at about 1.5 dB dropping. So we could perhaps improve that slightly, get it flatter. So we'll have a fiddle, but I think I can live with that. Boy, oh boy, it is getting late. It's 10 o'clock. It's a school night. This is my QRP DCT transceiver set up on 40 meters. And if we pan across our beautiful cheap Chinese amplifier with our new FETs from Mini Kits, and over here, of course, we have the low pass filter installed. And I'll just pop you up to the meter and we'll have a look at what power we're getting out. And this is the power output. And that's the 200 watt scale. It's up over 30 watts, 35, 36 watts. Very happy with that. And something that should be noted, I'll just show you what's going on over here because it's not an ideal setup. That is a QRP Labs QRP transceiver plug, a very lightweight. So I'm probably losing some voltage there as well. So that's probably going to be limiting me a little bit as well. So I'd say we've probably got 36, 37 watts coming out of this amp, and we will get this wired up correctly. And I have found myself a fan from an old computer power supply, and that's going to sit under the heatsink on the amplifier to keep it nice and cool. And we're going to see if we can smash out some FT8 on this thing and see how long it takes before it explodes and catches on fire. Well, check it out. We've got an answer from a Japanese station, and also we've got a QSO with Whiskey 7 Zulu Romeo in the States. And that is the first time that we have operated this amp. And I will shortly activate transmit on it and just show you how much power we're getting. But a little bit about the setup here. Very rough and ready, as you can see. I've gotten two of those leads out of my Arduino play around muck around kit, and that is running down to alligator clips which are coming off the 3.5mm stereo jack that runs out of the Hermes Lite, which is in a bit of a state of disarray because I had to get to the back of it, and I had to get to the back of the antenna box as well. But we have managed to nab a QSO, a DX QSO, and I'll just hit transmit just to show you. We might try for that Japanese station again. Let's enable transmit. And I'll just come over here and I'll just show you. This is on the 200 watt scale. And there you have it, folks. It's about 45 watts, close to 50 watts on peak. We are getting out. Very exciting.